micron is a millionth of a meter. A piece of dirt, which is 8 microns across, chunk of dust, it can stop a connector set from working properly if that chunk of dust is right in the center, holding between the two tips of the connectors. This is where we use this guy. This guy is a cable jacket scorer. It's very important we understand that with fiber cable, we don't use our standard tools, our electrical tools. We don't grip it and strip it. We're going to ruin the fiber if we do that. So we're going to use this guy right here. And what this guy has got is it's got a little razor blade there, and the razor blade is going to score. You don't want to cut through this jacket because you're going to be putting a metal-edged instrument on a strand of glass and it's probably going to break. So you want to score the jacket, and here's how you do it. This thing is spring-loaded, so you put it on the cable. Get on there, boy. And now you don't squeeze it, okay? You just let it do the squeezing itself, and you spin it around your jacket a couple of times, and you'll feel it actually break loose. And you see here where, yeah, it did actually kind of cut through, but that's okay, because every fiber cable has Kevlar, that's the yellow stuff here. It's a bulletproof vest. Now, the reason you might have to adjust the stripper is, let's say you start stripping the fiber and it breaks and it breaks and it breaks. It doesn't strip, it breaks. Well, that could be that this little hole here that we're putting the fiber in is too small. We want that hole to be about 140 microns, which is real small, and you can't measure it really. So what you want to do is you want to take this Allen wrench here and you want to put it into the adjustment port here, and you can feel it hook up. Now, if you ever do adjust this, if you want it to, if it's breaking the fiber, you want to make the hole a little bigger. You turn it clockwise and only turn it half a turn, and that will make the hole bigger. If you find that you're taking off the 900 micron jacket without taking off the buffer coating, then the hole is too big, in which case you would turn this counterclockwise, half a turn only. This is very fine measurements. We talked earlier about precision. Well, this is very fine measurement stuff we're doing here. So, very fine adjustments, I should say. So remember, half a turn only, clockwise to make it bigger if you're breaking the fiber, counterclockwise if you're not getting the buffer coating off. Okay? How does the cleaver work? Over here, there is a blade, and it's a round blade. You can see it here. Okay, there's the round blade. And you notice it has numbers on it because you can actually rotate the blade. It's very sharp, but you can rotate the blade if you start getting a bunch of bad cleaves and you get to a fresh part of the blade that hasn't been used. Therefore, it should cleave better that way. Now, so that's the blade that does the actual scoring of the fiber. And now I take the connector and I stick the ferrule, that's the tip that's sticking out of the connector, the white tip there. I stick that into the it's properly sized here, the feed hole where the laser comes out. And I stick it in there and I slide it all the way in. Now notice here that we have a bright red light there. That's the laser light that's coming through because the connector has not been finished yet. Now I'm going to try to do this. It's a little tough over the shoulder, but I'm going to try to do this. Here's what we're going to do. On the end of the connector, there is an open hole, the trough, if you will. And that's where we're going to slide our fiber in. Now when you're sliding your fiber in, you don't want to pull it in and out, okay? What you want to do is slide it in. I'm going to have to move a little bit here to get it started there. You want to slide it in, and now, do you see what has happened? You see how the light has gotten very dim? That's good. That means I got a good connector. Now notice I just turned the fiber a little bit and suddenly that light is a lot brighter. But if I turn it back the other way, I can make that light pretty much go out like that. Now, in your kit, you have a green, the industry calls it aqua, jumper cable. These are factory-made jumpers, and if you have to add to your kit or you need new jumpers for some reason, always buy factory-made ones. Don't make them yourself. Factory-made jumpers are made with special adhesives and a special method that makes them much more rugged than this thing that we built, right? This thing is relatively fragile. In fact, it needs to be terminated inside of a box so that it's not molested or mishandled. These are tough, and your test leads need to be two things. One, they need to be low loss, which is what you're going to get with a factory-made test lead, and also, or jumper test lead, same thing. Also, these are rugged and they can be used again and again. Okay, so that is, you get this, and with this we can connect up various cables and connectors and devices to see what they're putting out. You plug it into the laser tester, and the laser tester has a pulsing indicator here, and if we take a look, we can see the pulsing light right there.